With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The given question is a flat circular fixed disk has charge plus q uniformly distributed on the disk. A charge small plus q is thrown with kinetic energy k towards the disk along its axis. The charge q, and we are given four options, may hit the disk at the center, may return back along its path after touching the disk, may return back along its path without touching the disk, and any of the above three situations is possible depending on the magnitude of k. So let me first draw the figure and explain this. So let's say we have a disk, okay, like this. We are having a disk, okay. Now we are having, let's say its center at point O, okay, and we have a charge small q, okay, placed at a distance, let's say x apart, and here we have a charge plus q which is thrown at towards this disk with the initial kinetic energy k, okay, where k is the initial kinetic energy of the charge plus q, okay, with which this charge has been thrown towards the center of the disk, okay, let this be the center of the disk, and this charge and this disk is having a charge plus q uniformly distributed over its surface, okay. Now see, this plus q charge or this disk will apply a electrostatic force, okay, due to the electric field on this charge plus q in the opposite direction, okay, in this direction, and this force will be given as F equals to q into E vector, okay, or we can say Ex vector, because see, we know that if there is a disk like this, okay, with a charge, let's say plus q, and we have a point at which we have to find the electric field, thus we consider two small elements, okay, like this, equal and opposite of small length, which will apply electric field like this. So these electric fields will get equal, okay, in magnitude, and if we substitute, if we break them into their components, so that their y components will cancel out, okay, and the resultant electric fields become in the direction of, becomes in the x direction only, okay, we get in the x direction only. Hence the electric field acting on this charge small q will be acting in the positive x direction, okay, due to this plus q charge, and this electric field Ex can be given as 2 pi into k into sigma, where sigma is the surface charge density, 1 minus we have x, okay, we have considered this distance to be x, okay, x divided by we have x plus, so let's say the radius of this ring be capital R, so x square plus r square whole divided by whole under the root, okay, so this is the value of Ex, where this k is the Coulombian constant, let this be k dash, okay. Now see, when this charge is moving with some initial kinetic energy, there will be a retarding force which is acting on this charge plus q due to this plus q charge, okay, on the ring or on the disk, and this disk is said to be fixed, okay, and this charge plus q will be moving towards the disk only, okay, and in the given options we have, so let's check option one by one. We have A, B, C, and D option. So in option 1 it is given that the charge q will hit the disk at the center. Now see, if I say that this kinetic energy given to the plus q charge is more dominant than the work done by this force on the charge, then it might be a possibility that this plus q charge will move and it will hit the center of the disk, right? So this will be a possibility or possible answer. Next we have is, it may return back along its path after touching the disk. Now see, once it will have a sufficient energy and it will hit the center O, okay, then after that this force may take over, and this force, due to this force, this charge plus q will be returned back on this same path in this direction, right? Hence we can say that option B is a completely or is a possibility that may be true. Next we have is may return back along its path without touching the disk. Okay, now let's say we are given an initial kinetic energy to the charge, and let's say the charge has reached this point P. Okay, now after reaching this point, all the kinetic energy of the charge has been exhausted due to this retarding force. Okay, and what this force will do, it will again move the charge in the backward direction along the same path. So it may be a possibility that this charge will not touch the center of the disk and it may return back, okay, along its path without touching the disk. Okay, so this can be another answer. Okay, see, all these three options will be depending on what amount of kinetic energy is being given to this charge plus q. Okay, whether this kinetic energy is dominant or whether this work done by this force is dominant. And in option D, we have any of the above three situations is possible depending upon the magnitude of K. Okay, as I already mentioned, that this plus Q will hit the disk at the center or not will be completely depending on the value of kinetic energy. Initial kinetic energy given to this charge plus Q. Hence, from the given all the four options, option D would be the correct answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.